All right, as we prepare for the FAA knowledge exam for Part 107, we want to review a few things, aircraft performance being one of those as well. Remember that flying drones is a delicate balancing act. And remember that we have the four forces of flight. There'll be questions on that: lift opposing drag, lift opposing weight, and thrust opposing drag. Maintaining proper weight and balance is critical to an aircraft's ability to maintain its center of gravity. That's the balancing part of it. If the center of gravity is not proper, it's not going to be flying safe or efficiently, for that matter. Okay? This graphic sort of reminds us of what's going on here. Overloading a UAV can put stress on its ability to maintain enough lift to fly, along with increasing the danger of causing some sort of structural damage. This graphic is classic, right? You put too much weight on it, it ain't going to leave the ground. But if it does leave the ground, it's going to be using full power constantly. Not going to maneuver very well, and the battery's going to run down fairly quickly. Okay, forward and aft CG affects its flight characteristics. And of course, we have pictures of airplanes is probably the most common way to visualize this whole idea of weight and balance. Drones are no different. Drones are aircraft, and you are becoming a pilot, a certified FAA pilot. So think about this, an aircraft with a forward CG, or center of gravity, that's what CG means, right? Center of gravity, will tend to pitch down. And now, okay, I get it. The drone flies all different directions, but you sort of get the concept, right? There is sort of a front of a drone, right? But you can fly backwards. It's not the same, but it is the same. Whatever side the center of gravity is further out, it's going to tend to pitch in that direction. So an aircraft, the aft CG, or at the tail end, will tend to pitch up. So an aircraft properly balanced is important for stability and control. Now, UAS, they all will have weight and balance limits. They will often not be published, though, because manufacturers are not basically most drones that are produced now are recreational drones. We use them professionally, yes. If it were professionally, and if the FAA wanted to, they could have regulation that would require having weight and balance and all these issues. But it's not that important at this point. It's important for us, though, to mentally understand the weight and balance issue and to make sure that when we do fly our drones, they are within balance and within weight as well. But they do have a weight limit. So adding extra weight to a UAV can limit its performance. In other words, less. Okay, so let's say the DJI advertises their drone to be able to fly for 30 minutes. If it's overloaded, it's not going to fly that long. Adding extra weight can cause a UAV to be unbalanced by shifting its CG as well. Here's a picture, and you may not have thought about this, and obviously it's a joke, right? A picture of a shopping cart. But if you hang something with a cord or a rope or something like that, it will have a tendency to shift back and forth. So balance is not, it's not stable. So we have to be concerned about that and be aware of that. Fixed-wing UAVs operate with wings to provide lift. Again, batteries typically produce power necessary for normal flight, but overweight, maybe not. Students may believe, of course, you might think just add a bigger battery, but the batteries weigh something as well, so there's a trade-off there. A heavier battery, bigger batteries, not necessarily going to mean you can overcome the fact that you've added more weight. It's going to require greater lift. So before we add extra weight, like a camera or a bigger battery, we want to consider that possibility. So for most of these recreational manufactured drones, we would have to do some test flying of our own. The larger, more professional drones, of course, will have these limits. So extra weight could mean the drone is too heavy to actually lift off, or it may cause the drone to become unbalanced by this weight that you're carrying shifting. Okay. Maximum gross weight will depend on some factors, the strength of the actual structure. I mean, The battery power as well, maximum gross weight depends on the battery power or even the propeller, the size of the propeller, the ability for the propeller to produce lift. Structure, when it says strength of the structure, we're talking about those arms that hold the motors, right? They do have limits. But when they say battery power, it depends. If you have a gasoline or nuclear powered drone, there's going to be some limits to that as well. Find it hard to believe that there's going to be a nuclear powered drone, but even a solar powered drone is going to have some limits. And propellers have a breaking point as well. And of course, there's a critical angle of attack issue as well. The propeller blades at one point will reach critical angle of attack and won't be able to provide enough lift to fly. So here's some of the factors. Overloading a UAV limits will affect battery life or reduce the battery life, will add stress to some of the parts, reduce its performance, shorten its lifespan, increase the angle of attack of the propeller blades, increases its stall speed. All right, how does a UAV compensate for additional weights? Well, we have different kinds of UAVs. We want to remember there are multi-copters, which we're most familiar with, and we have fixed-wing drones. Either way, lift must be increased. For multi-copter drones, like we are all familiar with, it simply needs more, you have to provide more motor thrust to compensate for the added weight. If you're on a fixed-wing drone, you also have the ability to increase the angle of attack, but we don't have that ability at this point because the propeller blades are fixed pitch, and they either go faster or slower. That's all we have control over for a multi-copter. So for a multi-copter, as it's being loaded heavier and heavier, more thrust is required from the propellers to increase the speed of the propeller blades, and that produces extra lift or more lift. If a UAV, a multi-copter UAV, is too severely overloaded, though, it may not be possible to increase that lift to the point. So it's either going to descend or stall, and if it stalls, it'll be descending very rapidly. So remember, of course, that angle of attack, this is an important concept now, and we'll discuss it later, but angle of attack is the angle between the relative wind and the chord line of the airfoil, and we'll talk about that later. All right. There's other factors that will cause reduced performance for your UAV. Like strong wind in the area. We talked extensively about that before in previous lessons. If you fly with the wind, you have a good ground speed, you're traveling pretty fast, but you might get to the point where you can't make it all the way back because of the headwind. High elevation, the higher you are, the thinner the air is, right? And the harder the propeller, or the more lift is going to be needed to support the same amount of weight that you would have supported easily at sea level. If you're on the top of a fairly high mountain, you might not, the air might be too thin to produce enough lift from the propeller blades to actually fly, or even if you did fly, you would not very well. High air temperature does the same thing. The hotter the air, the thinner the air is. That would affect your performance. High humidity as well, to a smaller effect, but still higher humidity. That means the water molecules are pushing the air molecules further apart, so the air is actually thinner, even though we tend to think of humid air being thick, but it's actually thinner. Weight also needs to be reduced may need to be reduced because of, so in these cases, strong wind, high elevation, high air temperature, high humidity, you might want to need to reduce the weight that you normally would be able to carry. But weight may also need to be reduced because of the fact that you're flying up a hill, or the launch area size, there's trees all around there that you can't, so there's other possibilities as well. Okay, shifting gears slightly, remember the 3 axes of rotation. These are test question items that you just need to understand. Again, the test questions, they're not wanting you to memorize a bunch of facts. They want you to understand the principle of what's going on here. There's pitch, roll, and yaw. As far as I know, the only question pertaining to these 3 axes of rotation is the question about what controls yaw, the rudder. I get it. You're saying, I don't have a rudder on my drone. They're talking about fixed-wing drones that will have a rudder. And fixed-wing drones will also have a roll, which would require ailerons on the wings, and pitch would be an elevator in the very back that would pitch the airplane up and down. But for as far as the written test, yaw is controlled by the rudder, the non-existent rudder in your case, but still. Let's see other information. Well, yeah, this is important. Yeah, there's the picture. Okay, this is important because the center of gravity is where all three of these axes intersect. That's how the aircraft is going to perform. So if the center of gravity is way to the very front of the drone, it's going to act really weird. It's not going to act proper. It's not going to be balanced. It's not going to perform like it ought to perform, but it will also be more difficult to control because it's not rotating around the center of gravity of the aircraft. That's why we mentioned this. All right, here's a question here. The CG on a UAV, can it change due to weight or external conditions? Sure it can. This guy has got a little bit of an issue here as well. If the oh, there we go. Forward CG will cause the multicopter to drift forward. This case, it looks to me anyway that the center of gravity is off to the side, so it's making it drift sideways. Aft CG will cause the multicopter to lift backwards. We mentioned that earlier, but this is a pretty good diagram. Load factor, oh, my picture's right in the way there, isn't it? But load factor G limits is another issue that we want to refresh our minds. We've talked about it before, but load factors and G limits. G limits are just gravity, units of gravity. G units, they're calling it here. Weight's not the only factor that affects the performance of a UAV, of course. The way the UAV is maneuvered also has an impact on the load experienced by the UAV. All right, wing loading is a measurement that relates to the aircraft's mass to its total wing area. Wing loading is calculated by taking the total weight of the aircraft, dividing it by the total surface of its wings or propeller blades. In straight and level flight, UAV rotors must support a load equal to the sum of the weight of the UAV and its contents. This specific weight for a UAV has a load factor of 1G. So this is in level flight, you've got 1G. However, whenever a UAV is flying along a curved path, like a turn or a climb or a descent, centrifugal force is created that acts to the outside of the curve and increases the weight. It increases the weight. Or another way to put it is it gives additional G units to the aircraft structure. The UAV must support that. The UAV is supported by the airplane's wings, of course, or the UAV's propellers in a steep turn is greater than an aircraft's total weight. And we'll look at a chart here in a second. But this is the principle here that you need to understand before you even come to the chart. So these are G factors can be looked at as load factors, additional load factor. And the factor just means this is a number that you need to multiply to the weight of the aircraft because of the centrifugal force on the aircraft in a turn or curved path. Different maneuvers create different centrifugal forces or G forces. Aircraft and UAV are constructed to withstand those factors. But there is a limit to those factors, and it does affect performance. So that's where we come up with the chart. The FAA has come up with this chart to give you an idea about how much the load factor is. And the questions, well, got a few questions here, but here's one simple one. A load factor chart helps to calculate how load factor increases as bank angle increases, right? So, for example, a 25-pound UAV enters a 60-degree bank angle, has a load factor that is 2 times greater than normal. So you can use one half of the chart. You can either both of them or just one half of it. Probably easiest just to do the left-hand side. So you look at the angle of bank, and the question is asking enter a 60-degree bank angle. So you find 60 degrees. See, it's the top is this angle of bank. You slide down to 60 degrees, and then you go over one. The load factor is 2.0. All they're asking is that you multiply the 1G load, how much the drone weighs, and it's listed there, 25, and the question it says 25 pounds. 25 times 2, that's the load factor. The answer to the question is 50 pounds. That's what the aircraft structure has to support in a 60-degree bank angle. That's just the bank angle of the turn or the curve path. And this is just how the questions go. The other way to do this is to, I don't know if, yeah, you can do it this way if you want to do it the hard way. You can go over to 60 degrees, right? Let me use the pen here. Hang on a second. We'll go over to 60 degrees right there. That's not right. Hang on. Let me use the red pen. 60 degrees is here. Go up, 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 up till it intercepts that line, and then you go over like this. And it says 2. Well, that's what it says over here. 60 degrees is 2. So you get it either way. It's not complicated. It should be really simple. Now, they'll come up with some oddball numbers. They'll come up with 30-degree bank turn. Well, now you got it a little more complicated. Some of you are really good at math. You can multiply 30 pounds times 1.154. Sure, or you are allowed to bring a little simple calculator to the exam for things like this. And sometimes under pressure, maybe you don't do math really well, even if you think you do. So maybe it'd be a good idea to pull your little calculator up and punch the numbers in there, okay? The rule for these testing centers is you have to take the batteries out. You can't have any memory in the battery or any memory capacity, even if you have so you got to take the battery out in their presence and show them you've erased all the memory, then you can put it back in there, because otherwise somebody could have all the test questions in there, right? That wouldn't be fair. Okay, so I think I beat that to death. Let's move on here. 25 times 2 is 50 pounds. Okay, and then let's talk about the critical angle of attack. This is an important thing as well. Ooh, now I got a red dot I can't get rid of. But anyway, critical angle of attack is the angle between the airfoil chord line that goes right from the trailing edge of the wing to the leading edge of the wing and the relative end. That's what angle of attack is. Critical is the angle where it no longer can support lift, because we talked about that before. The wind comes over the top of the wing. Pen, highlighter, pen. I would like pen. Okay, pen. The wind is coming like this, and there's a certain angle where, woo, it just won't stick to the wing, and it'll go like that, not producing that lift. That's the critical angle of attack, and that's somewhere, somewhere around 18 degrees, something like that, 16 to 18 degrees, 16 to 18 degrees. This angle between the wing and that angle right there, if it gets to be 16, more than 16, between 16 and 18, or even more than that, it's going to start stalling and not producing lift. So that's the critical angle of attack. That's what we call critical angle, where the airfoil curling is relative, where you actually have a stall. Angle of attack, without the critical part, that's just that angle. But the critical angle is where it no longer produces lift. Okay, so here we have some questions. Like before, we're going to answer a couple of these are actual test questions and answers. I will say that they do change these questions, and that may not be in the current test. Again, you're not supposed to be memorizing these answers, but if you see this and it looks familiar, then it may be helpful. That's not the point of this, is to understand. When loading cameras or other equipment on a UAS, mount the items in a way that what did we say? We said, who cares if it's visible to the visual observer? It's part of the drone. We don't care about that. C, can it be easily removed without the use of tools? Well, that'd be sort of nice, but the FAA doesn't care whether it's easy or not. For you, it's got to be B, right? So that's a no-brainer. You don't want it swinging around or to move and change the center of gravity. Okay. To ensure that UAV's center of gravity limits are not exceeded, follow the aircraft's loading instructions specified in the UAS registration document. No, that's just to register the drone so they can collect their $5 and know that you exist. Pilot operating handbook or UAS flight manual. Yeah, that could be. That sounds pretty likely. Aircraft weight and balance handbook. Well, that's sort of generic. That's just talking about. That's where you would go to find out information about weight and balance. So yeah, it's got to be B. It is. Wow, very good. That's specific about that particular airplane. Pilot operating handbook or U.S. flight manual specific to that airplane. That's why that answer is more correct. UAS is operated at a weight greater than its maximum allowable weight. What would be the result? Faster speed? Why would you say that? I scratched that one off right off the bat. Increased maneuverability? Nah, it can't be that one. It's got to be a C, or got to be A. So some of these questions, boom, you can go right through them. However, I will tell you, if you finish this test in 30 minutes, you need to spend a little more time going back and make sure you read this, because if it said, if a UAS is operated at a weight greater than its maximum allowable weight, what would not be the result? It could ask it that way, and if you read it that way, then you just jump to the wrong conclusion. So be careful. But this one, pretty easy. All right, another question here. A UAS is loaded with the most rearward center of gravity is, well, whenever we talk about being out of balance, we're talking about stability, right? Generally speaking, it's either stability or performance. So what's it got to do with speeds? It had nothing to do with speeds. C, again, another no-brainer. Less stable at all speeds. Doesn't matter. Okay, which of the following is true about weight and balance of a UAS? Which is true about, okay? So it's not saying which is not true, which is true. So CG cannot change in flight. That's not true, because that's what the previous question said, that's a danger. You don't want that to happen. Lateral CG is not important to U.S. operations. Did I not say it had nothing to do with the side of the drone goes all different directions? So it can't be that one. C is obviously the answer. Operation outside weight and balance limitations may result in a loss of control. See, these are pretty easy questions, but just want you to be thinking through them. Which is true about the weight and loading of a UAS? Pause it and figure this out yourself. I got bored and pushed the button. Yeah, both weight and balance limits are equally important to the safety of flight. All right, when operating an unmanned aircraft, the remote PIC should consider that the load factor on the wings or rotors may be increased any time CG is shifted. B, nah. Aircraft achieves sustained straight and level flight. That means it's 1G, right? If it's C is 1G. The aircraft is level, straight and level flight, it's got 1G. So it's not increasing anything. It's got to be A, right? Anything other than straight and level. Straight and level is when you have 1G, one level of gravity. That's like me sitting in this chair. I weigh exactly what I weigh. But if I were to fall from the top of a building, I would momentarily weigh nothing until I hit the ground. Then I'd weigh what I weigh. Anyway, A is the answer to that question. Okay, now here we go to the chart. If an aircraft weighs 20 pounds, what approximately weight would the aircraft structure be required to support during a 60-degree bank turn while in maintaining altitude? 40 pounds. So, of course, this question would be accompanied by go to figure 28 or whatever figure it is to find the chart. So, okay, fine. I'll look it up and we will go back to it. Yeah, It's this chart right here. It's figure 2, as a matter of fact. You'd go to that figure right there. Figure 2 would give you that chart. And this is available, that chart right there I just showed you will be available in your testing supplement. And you use that testing supplement page for this one too. Same with this question, you find the answer through the testing supplement. So hopefully you'll find this helpful. If you have any questions, though, remember my published office hours. You can call me, you can text me. Remember that you get points off if you text me after 10 o'clock at night or before 6 o'clock in the morning. Other than that, let me know if you got questions or concerns or something comes up. Yeah, let me know. I'm here to help. I have a lot invested in you passing this test. That's why I'm doing these videos, so you can go back and review them. All right, so thank you and have a good night.